Hello folks, well, it's probably my favourite type of set of all time. Another one using the Cyberne 134 chassis, it's the Harvard 420M. You get the top Cyberne chassis but with minimum controls. So unlike the Rotel 220, the York 861, where you get the chassis which has one lesser receive section, this is the exactly the same chassis you get in the Rotel 240, York 863 and Binatone 5-star. You get the bigger speaker with this as well. What a wonderful set. They were $89.99 and fantastic. And if it hadn't been for Thunderpole kindly providing that Thunderpole 3000 in the test vehicle, we would have been using Harvard 420Ms throughout, and nothing CBT would have been bothered to be tested. So, this is from Trucking and Farming. We better get our duster out, power lead and original coffin mic, brackets in there. So put that on one side, we'll get out the duster. Time warp. Right, we'll jot down the serial number. 111 03524. So there you go, my favourite set of all time. And you get the green display. I'm going to open this up just in case there's any shenanigans before we plug it in. I don't know when it was last powered up, so if it was new in a box we'd take even more precautions. Same colour as Rotels. It's quite cold and it's been like 1 degrees. I think it was even -1 overnight, and the problem there is that I'm all electric here, and I'm in the middle of nowhere and I get less electricity than if we were in a town. So I've only got 60 amps for the entire everything. So you know, dropping heaters off just when you want it to be able to do anything. I want to get as far as the deviation so I can turn the other test set off. It's only a couple of 100 watts, but I need all the power I can get today. I don't want to start having to run generators. We do have solar panels, and of course that helps, but it's not standalone. I don't think that's as tight as it ought to be. So we'll start, before Mr. Chippy complains on the air test, we'll just start by closing those leaves up. It's not just when they've been used, I suppose it weakens off anyway. Right, I'll get that plugged in. You know what, I took the power lead back, which we were using. I'm going to have to go and fetch it again. Oh, we must have sold that one, so we'll test another one. We'll start by plugging our extension speaker mounted on the wall into the public address socket. Get that connected to power. 9 volts. Just as a precaution, we're on, the current limit was 300 milliamps, we're drawing 200. We'll switch to PA, we'll go to 12 volts. We'll test that at 12 volts. We'll use our standard Cyberne replacement coffin mic. I'm looking for a socket on the side, but it's on the front on these. To which I can say good. Okay, let's see whether we get anything. It must be on the volume control because there's no mic gain. Testing 1 2, testing 1 2. Absolutely fine. It's a good start. So we'll step the power up to 13.8 volts. And we'll look for the pen. So public address work, the meter lamp works. Right, over to CB. Plug into, still using the speaker on the wall. That to halfway, that to full. And it's on channel 20. Let's put picture in picture on. And what are we doing? Wow. Are we on low power? Yes. Oh, 2.9 watts. Channel 40, 2.8 watts. Channel 1, 3.05 watts. Back to channel 20. Current consumption 905 milliamps. Low power. Ooh, 60 milliwatts. Now I suspect that we've got a dirty low power preset, so we'll apply the switch cleaner before we even start. That can be soaking in before we even get there. We'll do VCR as ever. I'll have to print off a sheet, unless there's one on my clipboard, which there could be. They kind of get tucked in with that day's jobs. Yeah, it's here. Channel 40, 4 volts. Let's do that then. So we'll go to channel 40. Let's turn the volume down. Okay, so test point, we want the negative prod onto that earth point. Test point 4, the test point 1 is the resistor for far side, and we want 4 volts on receive and 4 volts on transmit. Well, it isn't quite 4 volts, is it? So I will adjust that slightly. We never know which way it's going to be. It's going to be down. That'll do me. 4.07. It's going to transmit. 3.78. It's not really far enough to bother adjusting, but we will anyway. Right, we've got 4.0 something, back to receive, 4.0 something, back to transmit, 4.0 something. I'm very happy with that. So that's the VCO done. And it is important on this chassis, as it is on the Cyberne 002F chassis, and to some extent on the Uniden chassis, but rarely on the Maxon one. So, what with 3.0 3.7 plus 3.5, it's now 4 plus 4, which is where it should be. We'll have a look at frequency, but I've only just put the test equipment on 10 minutes ago, so I'll set it somewhere near. Oh, we're in black and white today, are we? No, we're in all kinds of things. We had a power failure last night. I got up in the night for a 10100, like you do, and while I was having a 10100, the power went off twice, each time for just 1 second. Now I've got automatic emergency lights here, you know, the luminaires with the built-in batteries, so it wasn't like you couldn't see anything at all. But of course all the clocks reset, and you think, no. Right, going to transmit. 27, oh, we're on channel 40, on channel 20. 27 79089. Right, we'll just pop that up. Not that high. I'll set it to 124 because we're still warming up. It'll probably need dropping by the time we're done, but 27 79079, wasn't it? 27 79124. And of course it should be 27 79125. Now, deviation, just for a quick check, while it's showing 1.8 on this test set, we'll do the transmitter before we start messing with the deviation, so the other test instrument's got time to warm up. Alright, we'll take that off. Actually, we could use that for take that out, plug in our one for the speaker. Obviously not got it on Earth because it's, there we are. Right, let's get through this transmitter. So I want the 1.5 tool. Need to be on showing you the main meter. And transmit. Whoa, need to disconnect that Earth, otherwise we're going to get feedback. And we need to be on to be full power. The high-low power says attenuator, which is caught me out. So I want the centre of the peak, which is there. I'm still on the 3 watt scale, as you can see. Centre of the peak. Can get in for all the wires. Wow, that was out. That's now the centre of the peak. We'll go on to the other scale. It's 30 watt scale, so 4 watts is there. And that's peak. Usual thing with these, we have to initially set them to full whack. If you ever come across a set left in full whack, get it adjusted to 4 watts because it will melt the coils, apart from being illegal, of course. But it doesn't. There's no advantage in thrashing a set which is supposed to do 4 watts and getting 5 out of it. I can't even get. I can only just get 4.4 on this, and that's. We're going to have to do a little trick to get a little bit more. I have to up the power voltage. I can only get 4.2 in our setup, so I'm going to take the power supply up to 14 volts very temporarily just to set this. So it's now 4.45, so we need to take this one clockwise to get that point where it just starts moving down, and then we can take this down anti-clockwise to 4. Now we'll drop the voltage back to 13.8, which is there, and it's now 3.9, so we'll just pop that one back. There we go, that's 4 watts. So we want it to be within 0.1 on 40 and 1. and we have 3.95 on channel 40, and on channel 1 we've got dead on 4. So when that cools down, it'll probably be a little tiny bit over, but there we go. 3.95, 4 and 4. Let's sort out this. I'll tell you what, we'll do the meter first, because what's that say? I should have noted this before, just for giggles, and it's now showing 5. So we'll just pop that down to 4. Remember, this only reads the right amount into a dummy load, like we're using at the moment on the test gear. It might, when you've connected to an aerial, it might read 2. It might bang across. It doesn't mean the radio's doing more or less power. It's a relative power meter, and it's relative to SWR and reactance, etc. Right, that's that done. Let's do low power. Let's switch the attenuator on. We'll go to the 3 watt scale, and the radio's doing diddly squat. And it's going to be a dirty preset. I could even feel it was stuck in that position, and there we are at 400 milliwatts. So that's that fixed. And then we take that back to normal power. Let's see what the current consumption now is. It's now 1.147. Okay, let's look at receive. Put that earth back on. Not getting a good connection on that for some reason. Okay, channel. Let's go to the frequency counter, and oh, it's colour now. 2779125. I'll switch the other gear on. So I need to. So I've had to take the heater off in this room just to, and it's only 500 watts, just to be able to use the test kit. 2779125. That'll do nicely. So let's see what we're getting. Oh, it's another fantastic set, this. And I'm not saying that because I like them. So, as presented, it's 0.29 microvolts. For 10 dB, 0.24. For 20 dB, 0.51. Squelch to full. I'll make sure I've got the RF gain up. I have. Squelch to full. Want it to be 100 microvolts. It's 30, it's too weak. In fact, let's get a more accurate. It's 29. 29 microvolts. Do the opposite, go for minimum. Switch the signal generator to standby. I'll show you the attenuator. Put the squelch to threshold on the radio. And switch the signal generator back on. It's straight in at 0.3. The S meter, meanwhile, is reading what? That's 100 microvolts signal, and it's virtually bang on the S9. Let's just tell you exactly what it is. And it is 100 and... no, it's 55 microvolts. Now, if that was a ham radio, it would be right, because that's 56 microvolts for HF ham radio, but this is CB and it's UK, and it's 100 microvolts, and we've got 55 microvolts. So all the switches work, all the sockets work, and we're still working on the potentiometers. Right, let's see whether we can get a bit more out of it. It'd be nice if we could get it down to 0.21, but we can't on all samples. Right, let's go over to the SINAD meter. No, we won't. We'll go to the oscilloscope. Change my mind. If you change your mind, take a chance, Adabba. So 100 microvolts. There we go. Just a bit more volume so we get quite a decent trace. I've got the 2mm one. Oh, I need the 2mm one. There's the detector. Is it right or wrong? It's wrong. It's quite a bit out. In that case, I'm going to need to just do the... I'm going to have to do the IF, and I'll do that next. So I'm looking at the oscilloscope, the SINAD meter, which I'll show you, and I'm looking at the meter on the front as well for the IF. And we'll start with the one down there. Probably the most difficult one to set. Just drop my signal a fraction, because it did make a tiny difference. Next one. That was absolutely spot on as it was. This is the extra one you get on this chassis. And that was spot on. Right, we'll now go solely to the SINAD meter. And I want the 1.5 tool, which is that one. That is my dodgy... Oh, it's a squelch. I want a lower signal now. Yep, that's peak. That was spot on. Fraction there. So detector, this IF, and that one will just a little bit out, but it makes all the difference. So let's look for our new SINAD reading. I can think that's on 12. 0.21. We've got it. 0.21. 10 dB. 0.2. Could be just less than that. But we're between scales, so I can't really tell you any lower. 0.2 microvolts. And our 20 is 0.36. Often when the detector's out, you've got false better sensitivity, but in this case it's got better, so that's even more fantastic. Let's have a look at the S meter. So put 100 microvolts on the signal generator, and what have we now? Well, we just need to touch that. That's the signal meter. There we go, 100 microvolts. I'll just turn the volume down because not everybody likes a 1 kilohertz tone. I put it in the wrong one, hadn't I? It's 4. It was 56 microvolts. Now it's 100. So we've just got squelch to do. Now, because the detector affects the squelch, we'll recheck it without making any adjustment. So squelch to full. So 10:30, yeah, nearly came in. But you know what? It hasn't come in, so it's now fixed itself. Let's see where the other sensitivity is. Squelch is the one down there, but we don't need to do it because it's come right with adjusting the detector, which isn't surprising. So that's now 100 microvolts. We'll just check the sensitivity. So squelch off. Set it to threshold on the radio. Signal generator is on standby, and it's parked at 0.3 of a microvolt. Signal generator back on. Straight in at 0.3, just like it was before. Here we go, we're done. I'm just going to recheck. We need to do the deviation, don't we? So the thing about this, we've got this pesky extra one on this on these, haven't we? So I want that to the central position, and I will plug into the other test set behind me. And that should now, it must be about half an hour since I started. Wow, it's nearly there. It's 2.3, so the very slightest on that. Wow, that's it. And I've got a peak of 2.5. I can turn that off. The meter says on the Marconi test set, wow, it's reading low at the moment, so that's why we don't trust it. It needs capacity doing, which it's not going to get. So it was, it probably was 1.8, but it's 2.2 to 2.5 kilohertz now. That is a lovely radio. It's immaculate and it's a lovely performer. I mean, a lot of the time you get really scruffy sets. Look, you get the biggest speaker, and they work really, really well. You know, a lot of sets with a lot of wear on them. They've obviously been successfully in use for decades, but the immaculate ones can sometimes be returns. This isn't the case. Apart from that detector, would have been a little bit garbled on receive with it like that, and of course it's a bit low on power, wasn't it? And in at that kind of level, you are going to start noticing it's going to be slightly low, and the deviation was a bit low, so it needed doing. It's been done. There's the 4 screws. Pop them back. Those speakers are the same one used in the 76900 base station. For your £369, you see, you got a 3.5-inch speaker. But you know what? The Fidelity 2000 has the bigger speaker too. Not the 2001, the 2000. And the Banatone 5-star. You buy a new set today, you're lucky to get a 2.5-inch speaker. I think with new sets you'd be lucky to get 7 years as well out of them. I mean, not only is this 40 odd years old, I can't see any reason why it's not going to do another 40 odd years. Right, unplugging from the test gear, switch the test gear off and plug in the aerial. I've done this in one session. I normally have to do so many other things. Right, mega sensitive. I'm still plugged in there. One and a Roger. None of you waiting for the channels to lock. You know, a lot of not new sets. It's turn, wait, turn, wait, turn, wait. But no. No, nobody on. There we go. That's beautiful performer, and I'm glad it is because I love these sets. So thanks for watching the boxed Harvard 420M belonging to the gentleman from the trucking and farming business.